Hey, welcome back. We've just created a bullet hit interface and we're implementing this on the enemy class, which means that we get to inherit this bullet hit function, which we created an override for. And in enemy.cpp, we have the bullet hit implementation function, and so far it's empty. But we'd like to do a few things whenever the enemy gets hit by a bullet. Well, we created a impact sound and impact particles. So we'd like to play the sound and spawn the particles on impact. We're going to do that here in bullet hit implementation. Now, in order to play sounds and spawn particles, we're going to need gameplay statics. So we need to include that at the top. Now, the include for gameplay statics is kismet/gameplay-statics.h. Now, since we're playing sounds and spawning particles, we need to include those header files as well. Now, if we go to shootercharacter.cpp, we'll see that we have the includes for the headers that we need. So here we have the sound cue header and sound/sound cue. We're going to include that. So copy that over, paste it in enemy.cpp, and also we're going to need the particle system component. So let's copy that as well. So now we have the headers we need. We can play the sound and spawn the particles. So first let's play the sound. We're going to check to see if that sound is valid. We called it impact sound. So let's check to see if impact sound is not a null pointer. If it passes this check, then we can call gameplay statics play sound at location. Now it takes a world context object. We're going to pass in this, and the sound is going to be impact sound. Now for the location, we can simply call getActorLocation. And the rest of the inputs have default values that we can leave as is. So we're going to leave this function call like this. Next, we can check to see if our particle system is valid. So let's say if impact particles, and then we can call gameplay statics spawn emitter at location. Now this function takes a world, so we're going to call getWorld. And next it needs the particle system. We're going to use impact particles. Now, if you look at the second override for this function, it takes an F vector and an F rotator for the location and rotation. We're going to use the location in our hit result. So let's get our hit results dot location and pass that in. And for the rotation, we can just create a rotator. So let's say F rotator and pass in 0.f, and that'll create a 0 rotator for us. Now, the next parameter is a Boolean for whether or not to auto-destroy this particle system. Let's pass in true. And the rest of the parameters have default values. So we can end this here. And now we have our function call to spawn the particles. So we've implemented this function, but when do we actually call it? Well, we can call this from the shooter character class. So let's go to shootercharacter.cpp and take a look at the fire weapon function. Now here's fire weapon, and we do several things here, but all the line tracing takes place in our send bullet function. So let's go to that function. So here we have our send bullet function, and at the end of it, we call the get beam end location, which takes in an F vector called beam end. This gives us the impact location of the line trace when we fire the weapon and actually hit something. Now let's take a look at getBeamEndLocation. If we go to this function, we'll see that it takes an F vector for the muzzle socket location and an F vector for the out beam location. The beam location is passed in by reference that's not const, so we're setting the out beam location and using that after we call this function. Now we're creating an F hit result called weapon trace hit here in the function. And we're going to need this F hit result. So what we can do is instead of passing in an F vector by a non-const reference, we can pass in an fHit result and get that f vector from the fHit result. So let's go ahead and change getBeamEndLocation so that we can have the hit result and not just the vector. Let's go to shooterCharacter.h and look for getBeamEndLocation. So here's the function, and we're going to change the function's signature. Instead of fVector, we're going to use fHitResult. And let's call this outHitResult. Now we need to also change the function header in shooterCharacter.cpp. So let's go back and find getBeamEndLocation. And here, instead of an fVector, we're going to use an fHitResult called outHitResult. Now the first thing we do in getBeamEndLocation is we perform a trace. Now we used to have this outBeamLocation as an input parameter, but now we're using an fHitResult instead. So what we can do is create a local fVector here at the top of the function. Let's do that. And let's call this outBeamLocation. And now everywhere we used outBeamLocation, we'll be using this local fVector. So we're tracing under the crosshairs, and we're setting outBeamLocation to a value in that function. We're also setting it here in this if check. And then down here, we're using outBeamLocation in the line trace from the weapon barrel. And we're creating a local fHitResult for this. But now we're passing in an fHitResult by a non-const reference. This is the fHitResult we should be using for our final line trace down here. So instead of using weapon trace hit, we should be using outHitResult. So let's remove the weapon trace hit declaration. And instead, we're going to pass outHitResult into our line trace. And now this if statement is going to check if outHitResult has a blocking hit. Now outHitResult already has the results from the line trace inside of it. But if the hit result fails and there is no blocking hit, then the result that we're returning needs to have this outBeamLocation as its location. So what we can do is change this if check to see if outHitResult does not have a blocking hit. So we'll use the negation operator here. And if we don't have a blocking hit, then we need to set the outHitResult location. And we're going to set that to this local variable outBeamLocation. Now, if we reach the inside of this if check, then there was no blocking hit, which means we now need to return false. But if we never reach the inside of this if check, then we did get a blocking hit, which means we can return true. So now this function takes a hit result, and we can use that hit result in order to get the beam location. So let's go back to the location in our code where we're calling getBeamEndLocation. And where we used to create a vector and pass that in, we now need to create an fHitResult. So let's call this BeamHitResult instead of BeamEnd. And when we call getBeamEndLocation, we need to pass in BeamHitResult instead. Now, if the function returns true, then BeamEnd is true, and we get inside this if check. Now, the first thing I'm going to do is down here where we check to see if beam is valid, we need to set this vector parameter, and where we used to use BeamEnd, now we're going to use BeamHitResult.location. And here where we're spawning impact particles, instead of BeamEnd, we can pass BeamHitResult.location as well. Now these impact particles are spawned whenever we hit something, but we only want to spawn this if we're hitting something that doesn't have its own interface function for being hit by a bullet, like our enemy class. So let's go ahead and make a check to see if we're hitting something that implements the interface. So we're going to check our hit result and see what it is we're hitting. So let's add a comment and say, does hit actor implement bullet hit interface? And we're going to add an if check, and we'll say beam hit result dot actor. And if you hover over actor, you'll see that this is a T weak object pointer. So since actor is a T weak object pointer, we need to call its isValid function to make sure that we're not trying to access a null pointer. Now we can check to see if this actor implements the iBulletHit interface. Now we need to include the header for the bullet hit interface at the top. So let's go ahead and do that here. So we'll say include bullet hit interface. Now here's how we check to see if the actor implements the interface. We create a local pointer of type iBulletHit interface. Let's call this bullet hit interface. Now we're going to set it equal to the result of a cast. We're going to take the beam hit result dot actor, and we're going to call the get function so we can dereference the weak pointer. Now we're going to cast this to iBulletHit interface. So cast iBulletHit interface. Now here's what's going to happen. If the hit actor implements the interface, then the cast will be successful. Now we can see why if we go over to enemy.h. You'll see that enemy inherits from character as well as iBulletHit interface. So if an enemy is cast to iBulletHit interface, the cast will succeed. So this cast will succeed if we hit an enemy, since the enemy inherits from bullet hit interface. That means after we perform this cast, we can check to see if bullet hit interface is null. So we're going to say if bullet hit interface, and if we reach the inside of this if statement, then we just hit something that implements bullet hit interface. If that's the case, we can call that interface function. So let's do that. We'll say bullet hit interface, and we'll call bullet hit, and we have to call the implementation version. That's the version we implemented on the enemy class. Now this takes an F hit result. We're going to pass beam hit result to this function. So now when we've hit an enemy with a bullet, then we'll get the hit result, get the actor from the hit result, check to see if it's valid, and cast that actor to a bullet hit interface. And if that cast succeeds, we'll call the bullet hit implementation function. Now, if we hit an actor that does not implement the interface, then we want to spawn our impact particles that exist on the shooter character class. We can think of these as the default particles. So what we'll go ahead and do is place these in an else here. So if the actor does not implement the interface, we'll have an else case. And in the else case, then we'll spawn these impact particles. So these will be sort of default particles. So let's put a comment here and say spawn default particles. Let's go ahead and compile this so we can test this out. Okay, so we're back in the editor and we need a sound to play when we hit the enemy. So let's go into our assets folder, into sounds and impacts. Now we have a bunch of impact sounds here that you should have if you've downloaded the impacts.zip from the GitHub page. So this link will be in the resources for this video. So if you haven't downloaded that, go ahead, download it, extract it, and import those sounds into our project. Now we have some sound impacts here, and we're going to create a sound cue for when our bullet hits flesh, such as our enemy here. So let's take a look at the sounds we have. Now you'll see that we have some sounds called SW Impact AK Flesh, and we have 1 through 10. So let's right click on flesh underscore 10 and create a cue, and we'll stay consistent with our naming conventions. Let's call this flesh hit underscore cue. Now double click to open flesh hit cue, and we have the flesh 10 sound, but we want 1 through 9 as well. So let's get flesh 01 through flesh 09, highlight all of those, and drag them into flesh hit queue and release here. So now we have all 10. Now we can go ahead and highlight all 10 nodes, right click and create a random node, and all 10 will be plugged in. Go ahead and hook up the random node to the output node, and now we have a sound cue with 10 different flesh hit sounds, and each time it plays we'll get a random one. So we'll use this flesh hit cue. So we can set this in our enemy blueprint. So let's go into our enemies folder and open enemy BP. Let's open the full blueprint editor, and here we can set the impact particles and impact sound. For impact sound, we're going to select flesh hit cue, and we'll go ahead and use that. Now for impact particles, let's go into the Paragon Grux folder, and you'll see that we have an effects folder. Go ahead and open that, go to particles, abilities, primary, effects, and you'll see that we have P Grux apply bleed. Open that, and we get this blood splatter effect, and this is pretty cool because it's a sort of orange blood splatter, so it's not really a human blood splatter. It's more appropriate for a monster like this guy. So we're going to use P Grux apply bleed. So go ahead and set impact particles to P underscore Grux apply bleed. All right, let's compile and save. And I'm going to hit save all just to make sure that all of our work is saved before we test this out. So now we can hit play, and let's go ahead and shoot this monster with some of our guns. So not only are we getting the blood splatter, but we're getting also that sound cue for the impact of a bullet on flesh. So that sounds great. Okay, that's going to go ahead and conclude this video. In the next video, we're going to find more uses for the bullet hit interface. I'll see you then.